Now we will explore asynchronous JavaScript, focusing on promises and the async and or await syntax that is introduced in ES6. So asynchronous programming is essential for handling operations like API request, file input, output, and other tasks that takes time to complete without blocking the execution of your code. Now, a promise is an object representing the eventual completion or failure of asynchronous operation. So it allows you to write asynchronous code that is easier to read and maintain. And then the promises have three states: pending, which is the initial state, neither fulfilled nor rejected, and then fulfilled, that's the operation completed successfully, and then rejected, the operation failed. Now, let's go ahead and create a new, so I'm going to close everything here that I do not need, and we're going to go ahead and add a new folder called promises. Right, so in promises we have two files, index.html, and then another file called app.javascript. And of course here we just want to load our JavaScript file called app.js, all that we actually need to do here. Now, creating a promise is created using the promise constructor, which takes a function or an executor with two parameters, which is resolve and reject. Okay, so for example, it's new promise, and then it's gonna take two parameters, which is resolve and reject. Then we can set timeout. So then we have a constant success. So what we're doing here, we're actually simulating a success or failure. So if success, then we resolve data fetched successfully. Or else reject, failed to fetch data. Then we're gonna simulate 2 seconds delay. So this is measured in milliseconds. So there's 2000 milliseconds, which is equals to 2 seconds. All right, so here we simulate a 2 second delay. Then you can say fetch data dot then pass message. So this of course should output the data was fetched successfully. And then we can catch, if there's an error, we can catch an error. Then we just console dot error. If there was an error, that should actually say the data was fetched successfully, because we said success was true. What happens if we say success is false? If we change this to false, then then we'll actually output an error. Then it says failed to fetch data. Promises can also be chained to perform a series of asynchronous operations in sequence. Each then returns a new promise, allowing further chaining. Okay, let's say we have something like const fetch user is new promise, and then again we pass resolve or reject, and then set timeout. Let's say we've got a user ID 1, and then maybe say username John Doe, then with a delay of 1 second, and then we can fetch let's say we have a constant to called fetch a post of that user. So we're going to have a user ID here, and then here we're just going to return new promise, resolve, and then reject. Let's say we have an array of posts, so we will have post 1 and post 2, and then maybe a post 3 with a delay of 1 second. And then we can have fetch user console dot log, and then we're gonna return user dot user ID. So if there's an error, then we're gonna catch an error, catch error. So the output that we're expecting is the user fetched. You can actually see, so if we can see that the user is fetched, okay, which is John Doe, and then the array of posts is actually returned as well. So we can actually see post 1, post 2, post 3, which is an array of posts. All right, and then we also have asynchronous or async and await keywords. So those keywords, they provide a more readable and concise syntax for working with promises. An async function returns a promise, and then the await keyword is used to wait for the promise to resolve. Okay, for example, let's say we can have a function like async function get user data. Let's call it get user data, and then try const user. It's await fetch user, and then console dot log user fetched. And then we can do the same thing with the post const post await fetch post, and then user dot user ID. Let me just say post 2 because sorry, it's post. Just wanted to fix this, and then here we will actually log console dot log. So if there's an error, then we actually gonna catch the error, and you can just say error fetching data. Right, and then we can just evoke our function is get user. I can actually do this. I'm gonna go ahead and comment out everything else, maybe this one here. I'm gonna just comment out, and then we can just paste this one, okay, which is that a fetch user there. So it seems like it doesn't see it, and then if we go and check, then we can actually see. Okay, fetch post as well. I must actually do the oh yeah, I commented it out, so I'm just gonna recopy it, which is, let's do like that. All right, and we can just look at that, and then we can see now the user that is fetched and the post fetched. Now we also use the error handling here. All right, we use try and catch with async and await, which is the error handling. So error handling is crucial in asynchronous code just to ensure that any issues are actually caught and managed appropriately. So both promises and async or await have mechanisms for error handling as well. All right. Now, in summary, in this lesson, we covered the fundamentals of asynchronous JavaScript using promises and the async or await syntax. So understanding these concepts is really essential for handling asynchronous operations like network requests or file or input output and then timers effectively. Now, remember, promises provide a way to handle asynchronous operations with states of pending, fulfilled, or rejected. And creating and handling promises involves using new promise keyword, resolve and reject. And then chaining promises allows for a sequential execution of asynchronous tasks. Right? Async await syntax simplifies working with promises, making asynchronous code more readable and maintainable. And then error handling is actually crucial for managing issues in asynchronous operations using catch for promises and try and catch for async and await. So by mastering these concepts, you'll be well equipped to handle asynchronous tasks in JavaScript, leading to more efficient and effective code.